This project is about automatic fan control. It can be applied in various fields, for example, in hospitals. Somebody can also use it you can also use it at home. We have a passive infrared sensor that will detect if there's a human being in the room. If a human being enters the room, the fan will turn on. Then the speed of the fan will be controlled by a temperature sensor. In this case, I'm using LM35. Then we have an LCD here that displays the temperature reading and the motor condition. In this case, our motor is off because our PIR sensor, this is the PIR sensor, has not detected any human being. Then we are using our controller here is Arduino Uno board. Then we have the power source, we have the electronic parts also. We are using transistor to control our motor. For example, in this case, if it detects, I'm putting my hand here, as you can see. Now the motor condition is on and the fan is rotating, and the speed of the rotation of the fan can be increased or decreased using this temperature sensor. If temperature increases, the speed will also increase. If it decreases, the speed will also decrease. Well, now this is the circuit that I used. This is the circuit that you see there. We have the LCD. We are using an I2C, an integrated circuit. It has 4 ports. We have the VCC, ground, serial clock, and serial data. Our serial clock will be connected to pin A5, the analog pin 5 in our Arduino board. Then the SDL, serial data, will be connected to analog pin 4 in the Arduino Uno board. Then we have our motor here. Because our motor uses 12 volts, we love to control it, and we only need it to rotate in one direction because it is a fan. We don't need to reverse the rotation of our motor. So in this case, we are going to use a transistor. In this, I used a MOSFET NPN transistor. This is the circuit here. Then we also have a diode that is going to be connected in the motor positive and negative terminal. You find that when the motor is switched off, sometimes it has voltage spikes. So to protect our circuit, we are using a diode. In this case, we are using an N1N4007 diode. Then we have our temperature sensor. It also has 3 terminals. We have the VCC, the ground, and the output that is being connected to analog pin A0. Then we have our passive infrared sensor. It also has 3 terminals. The VCC connected to 5 volts, ground connected to the ground of the Arduino board. Then the output pin is connected to digital pin 2 in the Arduino board. Then our motor, the transistor has we have the collector, emitter, and the base. The base is connected to this transistor. We have a voltage divider circuit here with 1 kilo ohm resistor and 10 kilo ohm resistor. 10 kilo ohm resistor is connected to, is grounded. Then we have from the base, we are connecting the motor to digital pin 6 on the Arduino board. This is the circuit. These are the components that were used to build the circuit. We have the Arduino Uno board, passive infrared sensor, LM35, LCD, transistor, diode. Capacitor can also be used, but in this case I never used it. A 1K resistor, 10K resistor, a strip board. Then we have connecting wires. I also made a Proteus circuit, and these are the components that I used. We have 1N4007, this is the diode that I used. We have the second one here is 2N222, that is the transistor. Then we have the LCD. Then we have LM35, logic state. For example, if it is 1, it means it has detected motion. If it is 0, it means there's no motion detected. Then we have, because we are using an LCD I2C, we have that chip here. It is PCF8574. Then we have passive infrared sensor. Then our controller, microcontroller, Arduino Uno. This is the circuit, as you can see. This is the LCD. Then I2C chip. We are using PCF8574. Then we have our motor here. Then we are connecting it to the diode. Then the collector terminal of the transistor is connected to the negative terminal of the motor. Then the base goes to the Arduino Uno. Then the transmitter or the emitter is grounded. This is the Arduino Uno board. Then we have our LM35 temperature sensor and passive infrared sensor here. So this is the Protea circuit. The program that I used is here. This is the program. It is in the Arduino IDE. We have our library for our LCD, liquid crystal I2C.h. Then you have motor control pin, because we connected our motor to pin 6, digital pin. We are going to, then we have temperature sensor connected to analog pin A0. Then we have passive infrared sensor connected to digital pin 2. Then LCD that we are using is 16:2. Then on the void setup, we have set up motor control pin as output. Then set up passive infrared sensor pin as input. Then we have to initiate the LCD. This is the function for initiating the LCD. Then we are going to print the initial message on the LCD, temperature, then motor state, on or off. On the void loop, we are going to read the temperature from the LM35 sensor, in that when temperature increases, the speed of our motor will also increase, and if temperature decreases, the speed of the motor will also decrease. That is the condition we're going to use if else statement. Then we have a delay of 0.5 seconds before checking again for the conditions. This is the final demonstration on how our project works. As you can see, the LCD is displaying temperature reading and motor state. Our motor is now off. As you can see up here, the motor is off. Then on this side we have our LM35 temperature sensor. Then it is connected to power. Our Arduino is connected to 5 volts power. This is what I'm using as my power. Then we have 12 volts connected to our motor. The motor is connected. This adapter uses 12 volts, is giving us 12 volts that we're going to use to run our DC motor. Then we have our passive infrared sensor here, also connected to 5 volts power from the Arduino board. So now the motor state is off. So we want to turn it on, and to ensure that our sensor is working, it only detects a human being or an animal. That's how a passive infrared sensor works. It cannot detect obstacles from other objects. When I place my hand near this sensor, the motor turns on. As you can see now, our motor is running. Our temperature, the temperature of the room is 31.2 degrees Celsius. Now the motor is off. I want to try to turn it to use any other obstacle to see if what I'm saying is really true. Now I'm going to use this cooking stick to place it near my PIR sensor to see if the motor will turn on. As you can see, the state of our motor is still off because it has not because this does not produce any heat from the body or the body of an animal. So our motor state is still off. Our motor state is still off, as you can see here. The temperature reading is 31.2 degrees Celsius and the motor state is off. And this cooking stick cannot turn our motor on. But when I place my hand here, the motor state is on and our fan is running. So the PIR sensor is working well and we have achieved our objective to use this PIR sensor to detect if somebody has entered the room, then the fan should be on. Then to control the speed of the fan, we are using this LM35 temperature sensor. Now I'm going to demonstrate if the speed of the motor is increasing or not increasing depending on the temperature. To confirm that if temperature increases, the speed of the motor also increases, I'm going to turn the motor on, then increase the temperature by placing the sensor near a light source. If I place the sensor near a light source, the temperature will increase, and we are going to see if the rotation of the motor also increases. Now I'm going to place my hand here to turn the motor on. Our motor is on now. Our motor is on and this is our light source. As you can see, the temperature is increasing, 33, and also the speed of the motor is also increasing. Now it's 135 revolutions per minute, as you can see up here. I don't know if you can see it. The motor is on. The revolution has also increased. That our temperature is 34 degrees Celsius. It is 149. The temperature now is 35. Let me place my hand again around this to increase. So you see, if the temperature increases, The speed of the motor also increases here. And as the temperature decreases, as you can see, the speed of the motor also decreases. The power adapter that I used is here. It has an input of 100 to 240 volts, then the output is 15 volts, 2 amps. The Arduino Uno board uses 5 volts. It is powered by 5 volts, or you can use the 9 volts battery or any other source that is compatible with the board. This is the block diagram for the project. We have the power supply, temperature, and passive infrared sensor as the inputs. Then we have our output here. We have fan and LCD. A very simple block diagram.